Hello everyone, welcome to chemistry class. We are here with the part 2 of the chapter 4 atoms, molecules and radicals. In the last video discussed about the atoms, what these are, then we discussed about the valency and the various forms of it being classified into the elements as monovalent, divalent, trivalent and the tetravalent. Today we'll discuss and continue the topic and we'll continue towards molecules. So as we discussed last time about the atoms, that these are the smallest particle present in any of the chemical reactions. So after the chemical reaction is complete, atom cannot remain independent of on its own. It does not remain alone. So normally in usual manners, atoms do not remain alone and always they will combine. Whenever the atoms combine, what will happen? They will form groups, and those groups only, or groups of atoms, are called as molecules. So that will be the definition of the molecule now. It is the smallest part of the element that can exist independently. Yes, atom cannot remain independent, but molecule can remain independent. For example, hydrogen atom combines with another hydrogen atom, then what we'll get? We'll get what is called as hydrogen molecule. This is called H2 molecule because two atoms are there, that is why. So that is the definition what is a particular molecule. So whenever any atom is combining with another element, then only a molecule will form. Similarly, you can write for O2, that is oxygen molecule. It is produced how? It is produced by combining of different oxygen atoms. Oxygen atoms join only to produce the particular oxygen molecule. So here again another example, like nitrogen, it combines to form a molecule of the compound. Different atoms of nitrogen, two atoms will join, and what we will get? We will get in the ending, we will get nitrogen, N2 molecule will be produced. But in the case of the noble gases, which are not reacting with anything, helium, neon, argon, krypton, xenon, all these elements are unreactive, they are called inert gas. So in this case the atom will not combine. Yes, single atom can remain alone. In the noble gases, one atom is able to remain independent also. In normal cases, in other elements, one element atoms cannot be independent, but in the noble gases atoms can be independent. So if we talk about helium, for example, if we write He, then it is helium atom, and single atom only will behave as molecule also. So it can be represented as both. If we write He, it is an atom also, it is a molecule also. On the other side, if I write H, then it is only and only an atom, it is not a molecule. If we have to write hydrogen molecule, we have to write H2, but not in the noble gases. Same thing will represent both atom as well as molecule also. So that is why it is slightly different in the case of noble gases only. That is, they contain only one atom, and therefore we will say single molecule of a noble gas is having one atom only. So based on this only we will have what is called as atomicity of the various elements. So what is this atomicity? Atomicity is a concept based on what we can say. We can say this as the number of the atoms that are present in a particular molecule. So like in this case, you can see the noble gases, all these examples are there. In single molecule only one atom is there. Because only one atom is in one molecule, we will say its atomicity is 1, and therefore it is called as monoatomic. Atomicity क्या होता है? Atomicity is the number of atoms in a molecule, number of atoms present in a molecule. But in the noble gases, in one molecule only one atom is there, therefore noble gases are monoatomic. Mono means single, so their atomicity is 1 only. In the case of the this one, H2N2 Cl2 or O2, at the bottom you can see 2 is written. That means their atom is having 2 atoms. So if 2 atoms are there in the single molecule, these kind of elements are called as diatomic. Their atomicity is 2 and they are called as diatomic. Then what about 3? If 3 elements, if 3 atoms are present in a single molecule, then what will happen? They will be called as triatomic. Triatomic example is a gas called as ozone. 3 oxygen atoms are present in this O3 molecule. So therefore it is what? It is called as triatomic molecule. Similarly, another one, now we'll continue this, that is here atomicity of phosphorus. Phosphorus single atom is called single molecule is called P4. P4 means 4 atoms of phosphorus are present in the same molecule. Because atomicity is 4 here, it is called tetraatomic. The name will be given here as tetraatomic. Next, the last one is sulfur. Sulfur molecule is called as S8, means 8 atoms are there. 8 atoms of sulfur are there. Because 8 atoms are there, it is given name octa. Octa matlab hota hai 8. So octa atomic. So that is sulfur. So now in this table you can have a summary of all these. So you have to learn all these examples that are given in this table number 4.2. Put a tick in the book and you have to learn all of these. Monoatomic, only one atom is there. Diatomic, 2 atoms are there. Triatomic, 3. Tetraatomic, 4. And octaatomic, 8. Many others are also there that are not a part of your syllabus. We can skip that. Only these ones you have to learn: mono, di, tri, tetra and octaatomic. So this is what is called as atomicity. Atomicity, what it is, again I repeat, it is the number of atoms present in a single molecule. Now apart from this monoatomic, see here, monoatomic, only one atom is there. Apart from this, if more than one atom is there, 2, 3, 4, 8, whatever the number of atoms, it is more than one. So if more than one atom is there in a single molecule, then we can give it another name. Such kind of the molecules are also called as polyatomic. All these diatomic, triatomic, tetraatomic, octaatomic, all these are put in the single category, that is they can also be called as polyatomic because they are having more than one atom in their molecules. So that is a new term you have to remember. It is given here: a molecule having atoms greater than 2, polyatomic. Examples are O3, P4, S8. Up to 2 you can leave. I told diatomic also. Up to 2 you can leave. Other than that is polyatomic. More than 2 is polyatomic. So that is all about the atomicity. And whenever we write whatever is written here in the bracket part, you can see all these bracket part. All these are what? All these are formulas. Like in the elements we are writing symbols. In the case of the molecules we are writing by symbols. This can be also as a fill-ups. Molecules are represented by dash, you will write as formulas only, and as a formula only they are written. And it tells us what? Formula tells us the number of the atoms present of the same element, also of the different element. Different elements may be there in a molecule. Like in a water molecule, H2O is the water molecule. So that means what? It means 2 atoms of hydrogen, H2 is written, and O means 1 atom is there, 2 atoms of hydrogen. And secondly is what? I will change the color. Second is 1 atom is there of oxygen. So different atoms can also be there in a single molecule. So that is all about the molecules. Also we have completed. Now we will move towards the next part, that is formula of compounds and how to write them. This will be the topic to be discussed in the upcoming class. This video will wind up here. This table is your homework for now. You have to learn all these examples that are given in this table, and also the previous table. I hope you have learned already. Last week I told you. If you have not done, you can do so now. So that is all for this video. Thank you for now.